So what are some properties of exponents? Okay, so we talk about exponential growth continuing to go up the whole time. Okay, so properties of exponential growth are right here, right? We notice that our b, our base, is greater than 1, right? So anything that's greater than 1 is going to continue to go up. X is positive. Now, when x is positive, but we have a fraction, something between 0 and 1, that's when we have what's called exponential decay. And we have lots of different examples of exponential growth and exponential decay. Easy one, exponential growth. We talk about the cases of coronavirus in the U.S. Exponential growth, right? Started at 1, and eventually went up to whatever we're at now. Exponential decay, we can talk about, that's actually a good use of that, is how we discover how old bones and fossils and things like that are, because in every bone there's carbon atoms, carbon 14, and as those continue to break down and get smaller and smaller and smaller exponentially, we can figure out how old fossils and bones and things like that are from that. Interesting, right? Okay, so what do we know about this? Okay, well, we know that the asymptote for both of them is the x-axis. We both know that the y-intercept is always 1 for the parent function, and it's continuous the whole way. Okay, good. All right, so let's look at these and let's talk about some transformations. So to do that, we're actually going to look at, we're going to graph these in decimals. We're going to look at them and see what happens. Okay. So in this one, we see that we have the function f of x equals 2x. And now what we're going to do is we're going to look at it when it's 2 to the x plus 1 power. Okay, let's do that. So let's go here and look at decimals. And all right, so let's start by graphing our parent function. Okay, so we have 2 to the x power, right? This is our parent function in red, right? So let's look at what happens when we have 2 to the x plus 1 power. You'll notice that that is not x plus 1, but that is right here. What we're going to do is we're going to do this. We're going to put it in parentheses. Okay, so what happens to my graph when I add x plus 1? Well, what we see here is where we have the point 0, 2, and we have the point, you'll notice that I have the point negative 1, 1. So what ends up happening is my whole graph is actually moved 1 unit to the left, right? So that plus 1 moves our graph to the left 1 unit. Okay. So if we go back here, we see that when we have this, it translates graph f of x 1 unit left, right? It moved the whole thing left 1 unit. Okay, let's look at the next one. Instead of having 2 to the x, we're going to have 2 to the negative x. Okay, all right, so we'll get rid of this guy, and we'll look at 2 to the power of negative x. All right, so what does that do? So when it's negative, you'll see that it flipped the whole thing. It flipped it over the y-axis. Okay, so when we have negatives, it flips it over the y-axis. So this one, flip graph f of x over the y-axis. Okay, so when the exponent was negative, it flipped it over the y-axis. All right. Now we're going to look at j, which is negative 3 to the 2 times 2 to the x. Okay, so let's look at that guy. So we get negative 3 times 2 to the x. So what did that do? Okay, well, looking at this guy, what ends up happening is I had my graph, right? I see that my original in red there crossed at y-axis is 0, 1. But now this one, the new one, is at 0, negative 3. So I flipped it over the x-axis, not the y, but the x-axis, and I actually stretched it out by a factor of 3, because that's what multiplying by 3 is, okay? So what happened when we multiplied by -3? It took our graph, f of x, and it flipped it over the x-axis and stretched it by a factor of 3. So we'll say this, flipped graph f of x over x-axis, different, and stretched by a factor of 3. Okay? So it stretched it out by a factor of 3. So here's a couple graphs that I'd like you to look at and describe their translations now.